Hello, everybody. Give us a moment for AV wrangling.
Ooh, it is a very slippery podium, isn't it?
Wearing high heels was a solid decision for this. Everything is fine.
Okay. How are we doing? We're an extension, which we don't want to be. Which one did that come up on here? That's the one we want. Okay, and that's a talk.
Amazing. So we have some slides and stuff, and we wanted to introduce you how the fuck to do infrastructure as code. So my name's Alex. I'm a software developer. This is Duck. They are a site reliability engineer. We wrote an hour-long talk. We're going to condense it into half an hour, so I hope you're all hyped for like 30 minutes of real quick-fire infrastructure as code. So as I mentioned, I'm a developer. Duck is an SRE. Historically, relationships between ops and developers haven't been entirely cordial. One of us likes to ship things, and the other one wants us to stop breaking stuff. So we found that working together has led us to some really cool stuff, and that's why we wanted to talk together today, because we've been working on a little project together that we think is pretty cool. So you may have noticed that Duck's title is Site Reliability Engineer, but I've been talking about ops. You can fight me about these definitions later, but I will say that Site Reliability Engineer maybe is a little more focused on automating your infrastructure, so making it really repeatable. So yeah, we're going to talk to you about how to do infrastructure as code in a world where we're cloud native, right? So cloud providers make all of these amazing things that we can use. It means that our infrastructure looks super complicated, but the world of development is really closely tied to the infrastructure. And this kind of cultural shift of DevOps is a way that developers and operations people can communicate and work together on cool stuff. And infrastructure as code is an amazing tool for facilitating that kind of sharing. So some of the handy-dandy benefits. Infrastructure as code is super reusable, and that's across multiple dimensions. So we're going to run you through Terraform in particular, which has what we call modules, which you can think of as a particular resource, and you can write it up. If you're a developer, you can think of it like a class, right? Like a blueprint of something that you're going to instantiate. Also higher level, we can reuse modules. I said modules. Environments. You can reuse environments. And this is incredibly helpful for developers. So when I'm writing some code for a Lambda, something like that works great on my machine. The ability to spin up a production-like environment and actually test it, it lets me find out what's going to go wrong, because something is always going to bite you in the cloud. So another benefit is it's auditable. And we kind of get that one a little bit for free, because developers have been creating all of these tools, we call them version control or Git, things like that, to make sure that we have this great history of our code. So when you're putting your code, your infrastructure into code, you get all of these benefits as well. You can look at what changes were made when, you can tie it back to documentation, to decisions, stuff like that. Fantastic if you have PCI requirements or any other kind of compliance issues. Yeah. We may have worked in compliance environments before. And one of the great things, as I mentioned before, is that this is a shared responsibility, right? This tool, infrastructure as code, and the code base it creates, gives you a shared language, not just a technical one, but like a human one as well, to talk about what you're creating, what the outcomes of those things are. Makes it really easy to collaborate. And that's exactly what we've been doing. So in this talk, we're going to talk to you about AWS in particular, because they have a massive market share, and also that's where our shared experience is. We're going to talk about Terraform. Terraform is an infrastructure automation tool. It allows you to kind of declaratively state all of your cloud resources in essentially files that are code. One of the cool things about Terraform is that it is not cloud provider specific, and it works across GCP and Azure as well. Feel free to come ask me about that if you see me around KiwiCon. However, the code base that you write for one cloud provider will not apply across all of them, but the principles that we're going to run through today will apply. Cool. So how? How are we going to do this? Duck will tell you.
All right, so I want to focus on some of the bigger picture concepts around working in the cloud. There's a few really common mistakes that people make when they first move to AWS. The first one is how they manage their accounts, and the second is how they manage their users. So people get really excited, they go to move to the cloud, they get an AWS account, and they put all their experimentation in it, and then they put all their testing in it, and then they put all their production stuff in it. And then it ends up looking something like this. And a few months later, they have a really sad postmortem because someone accidentally hooked up their testing infrastructure to their production environment. It doesn't have to be that way. With AWS, you don't pay per account, you pay for the services used. So you're going to pay the same thing if you have all those in one AWS account or if you have it in multiple. So that means you can create a AWS account per environment you have, creating a permissions boundary between each of those environments that you have to explicitly decide to cross. What that's going to end up looking like is something like this. So the first account you're definitely going to need is a development environment. AWS is constantly changing, particularly right now. It's November, it's reInvent month. They're like a fire hose of new services and changing features, and it's just completely overwhelming. And you're going to need somewhere where everyone can go learn. Your SREs, your developers, your testers, everyone's going to need to work out how these things work in the cloud and also how to terraform them on their environments as well.
Everybody to the data center.
Yeah.
So one thing you might want to note with these, with different environments is that if you've worked in a traditional dev shop, you'll have different stability expectations, right? So you might have a production environment, pretty stable. We like to know what's going on. Testing and staging environments, you might have different expectations of stability. Things there can be a little more flexible. Development environment is a free-for-all, anything goes. There are no stability expectations, and I recommend winding everything down every evening, in fact. There are no guarantees in development.
Exactly. Keep it as a free-for-all. So, as Alex mentioned, the next two environments you're going to need are your testing and production environments. Your testing is obviously a black hole in this case. So, you're going to want to keep these as separate environments. Again, just that permissions boundary between what your testers are testing in and what your customers are using is super important. You don't want to accidentally wire those up, and this means you have to make explicit steps to accidentally cross those wires. The fourth account here is probably something you haven't really heard of before. I call it the admin account because it does administration-y stuff. I use it for shared resources that don't exactly exist in your testing and production environment. Things like building your machine images, your AMIs, or sending messages into your Slack account. Those don't need to exist with your testing and production infrastructure. You can keep them in a separate account. It's mostly an SRE land. But the thing I really want you to take away from this admin account is that you can use it to manage your users. It should contain all of your users, and you shouldn't have users in your testing and production environment. So in order to explain a little bit more about users, I'm going to have to talk to you about IAM, Identity and Access Management. I had to write it down because I never remember what it is. I just call it IAM. So I said a lot of people make a mistake with their users when they move to the cloud, and that mistake is that they want to get up and running as fast as possible. So they create a user for each of their devs in all of their environments, and they just give them all admin, and like, yeah, that's fast, but oh my gosh, it's a mess. You're managing everyone's permissions in so many different places, and it becomes chaos. And when you want to roll out a more granular permissions management strategy later on, it's really hard. Trying to take away people's permissions upsets them, surprise, surprise. And you also might end up breaking a bunch of the hacky workarounds that they've configured, and you're also changing their entire workflow, which is just going to slow down all your development later down the line. So you should try and get this right from the start. And in order to explain how to do it right, I'm going to have to show you a few base principles of IAM. So if you use AWS all the time, just bear with me for a minute. The first thing you're going to need to know about is IAM policies. IAM policies are sets of permissions that allow you to take actions against resources. Now this is an example of one written in Terraform. It's just a piece. So this one allows you to put objects and get objects from a specific S3 bucket. Now if you combine a bunch of different statements together, you can come up with an IAM policy. Every different service has a different set of actions you can do with it and on the resources in it. So now you've got a big policy. It allows you to do a bunch of stuff in the cloud. What do you do with that policy? You attach it to an IAM role. Now, you have a role with permissions. who or what can use that role? Actually, a bunch of different things can. Lambdas can use roles, EC2 instances can use roles, and so can your users. In order to decide who or what can use the role, you need another IAM policy. This one's a special one, though. It's called a trust policy. So it allows you to do the action assume role, and you can allow that to a principal. In this case, it's AWS, and it's going to be a Lambda. So a Lambda can use this role. But you can also decide that, you know what, I'm not going to pick anyone specific to use my role. It's just too hard, that's too much decision making, I don't want to take that responsibility. And the IAM role can instead say, that AWS account over there, that one is going to manage who can assume me and get my permissions. Yeah. So what does that look like? More like this. So you have an IAM role with some permissions on it, and that's in your test account. And it's got a trust policy which says the admin account is going to take care of this. It's going to have all the responsibility. Now in your admin account, which contains all your users, you have an IAM group. That's a group of users, and that IAM group also has a trust policy on it which says, hey, all the users in this group, they can assume that role over there in the test account. It's a two-way trust in order for you to be able to assume that role and get those permissions. Okay, are we all with me so far? Okay, because we're about to take this up another step. We can expand this concept out. Oh, I can hit the slide button too. There you go. So you get all these different roles with different levels of permissions on them, and you have all these different IAM groups for the different people in your engineering team. You can have groups for your testers, for your developers, for your on-call team, and for your SREs, and you can allow them to assume different roles and different accounts based on what they need to do. A big part of DevOps is about allowing people to do their job, giving them the permissions they need to achieve their goals, and this is how you can do it in a safe and manageable way. So what does this look like across all the accounts I showed you earlier? Well, it looks like this. I've chosen to use the example IAM groups of devs and SREs because that's what we are. As you can see, we've got different permissions in here. I can assume some roles in the admin account, and Alix can't. We can both assume different roles in production, and we can assume the same roles in test, giving us the freedom to do what we need to do in our environments. Now, IAM permissions are additive, so you can belong to multiple groups, and you end up with combinations of permissions, and you just keep gathering them. So that means that if you're a developer, you can be in the developer group, but if you're also on call, you can be in the on-call group as well, giving you those extra permissions you need when you're dealing with an incident. There's another group that everyone needs to be a part of, and that's going to be the all users group. This is what allows users to log in, change their password, and add an MFA device. It's the only permissions that a user has on by default, and any other read or write permissions, they have to assume a role to get them. So that was like a boatload of theory I just threw at you. What does that actually mean? What does that look like? How to use it? Well, time for a live demo. So exciting. I hope this works. So let me get my things ready. Can you see my screen? You can. So we're going to go to the AWS console. Is that big enough? Let's go a little bigger. Okay. So I'm going to log in with my, hold on.
We will accept any prayers to the demo gods while Duck does this. Thank you.
Ooh, into my password manager. I'm going to use my password manager to log in. And now I'm going to add my MFA when it gets there. One of the things we've added to the roles is that you have to have your MFA session active in order to assume roles. You can't just log in and assume a role. You have to be using MFA, which is super useful and adds some extra security. When it takes that, there we go. It's going over a hotspot on my phone, so it's a little slow, but we'll get there. So we log in.
Just wait and talk through the blank screen. Here we go.
Ooh, okay, so let's go see what we can do. Whew, this is riveting stuff, eh? All right, so we're getting all these errors. If I zoom right in there, I'm not authorized to perform anything. I can't do anything. What am I going to do? If I go look at the groups, I can't see anything. So instead, I'm going to go and switch a role over here. Now, in order to switch a role, I need to know the account ID, which I continually forget, so I'm going to copy it. And I need to know the role name. So you need to know some things about how the business is run before you can assume a role, which gives you some security through obscurity, but it's kind of good. I'm giving it a pretty display name so I can find it again later. And we're going to log in. And now, hopefully, you're going to see a bunch of groups. Yay! We have permissions now. We can do things. So you can also do this over the CLI. You can use a tool called AWS Vault, but I do not have time to demo that for you. But I highly recommend you use it and look it up. So now you know a bunch of stuff about what you can build. How do you actually do it? Let's just skip past my GIF in case the demo didn't work.
We did have a fallback GIF, just in case. So I'm going to chat to you a little bit now about what the actual Terraform looks like, how we take code that we write and turn that into magical cloud resources. So, oh, you rude creature.
Click on that.
Okay, cool. Oh, sorry. We're actually going to talk about Terraform first. So, you know how Duck told you about several accounts that you want to have? Each of those accounts needs to be somewhat configured in order to be able to run Terraform. So what we're going to do is we're going to run through the minimum viable Terraform config in order to get those accounts up and running. You could copy-paste this, but I think it's more illuminating about how Terraform works if we run through it. So the first little stanza that we're looking at there is the Terraform one. We've got a required version on it. This is the version of the binary that you are running on your computer. You have a little gotcha involved with this one, in that Terraform holds its state in a file, which we're going to store remotely. We'll cover that a little bit later. But that remote state file will lock to the latest version of the Terraform binary that it has seen. So you want to sort of manage your rollout of what version your developers are using of Terraform. Otherwise, some people will find that they're locked out of accessing the state file. The next thing we're going to look at is our provider. So hopefully, it's been clear we're talking about AWS so far. We also have a version there. The reason that the provider version is different from the Terraform version is that Terraform will ship improvements to their provider API frequently. As we mentioned before, AWS, in all their wisdom and grace, continually bestow upon us more and more cool things to use, so that provider resource increments quite frequently as Terraform enables us to take advantage of all of the cool cloud things. Also has a region, because it's AWS, and it has a list of allowed account IDs. So these are the account IDs that are permitted to make changes to the Terraform. And the final thing we're going to look at is the back end. So what this is referring to is where we host our state file. In Terraform, you can run a local state file, but you get a few benefits from hosting it remotely with your other cloud infrastructure. So one is that the state file will lock once someone starts making changes to it or starts looking at the changes compared from their local dev compared to the cloud. So when you get that, you can kind of ensure that you're not going to have your infrastructure in an inconsistent state. People aren't going to half update it. So it's incredibly helpful to have it hosted remotely. You definitely want to encrypt it. There are secrets in there. Let's keep those secret. The bucket name is just the name for the S3 bucket, and the key is essentially a path to that file. And again, region, because AWS. So what is this mysterious state file? The state file is where Terraform, the tool, stores all of the resources that it's going to configure for you in AWS. It's kind of Terraform's source of truth of what exists in AWS. So it has things like the resources that it is managing and the dependencies between them. So one of the examples that we ran through briefly was a Lambda. A Lambda needs a role in order to run in. To create a Lambda, you need to have that role already existing. Terraform takes care of figuring out that you need to create the role first, and then it can create the Lambda. Historically, other sort of infrastructure management tools have been more of the imperative variety, where the code that you write is a series of instructions. So I mentioned before that Terraform is declarative. What it does is it will figure out the difference between the state that you have declared and the existing state and figure out how to get there. Otherwise, you kind of have to manage all that in your mind. And once you get into these beautifully complex cloud-native solutions, that can be a bit tough. So that's our TF state file. So what happens is when we've made a few changes, maybe we've added our Lambda, we've added the role for the Lambda locally, we want to figure out, what is this going to look like on AWS? And we run a command in Terraform called plan. And what that does is it looks at the TF state file. So it goes off and it refreshes the TF state file, finds out what the current state of the infrastructure in AWS is, and diffs that against what we have locally, and it outputs a plan. So this is the command we run, Terraform plan, with an argument of with a command of plan.out, and we have a GIF here that's running. You don't need to read it, not important, but what it's doing there is it's refreshing, it's grabbing the new state, and then at the end, it outputs the diff for you. And you'll notice that we've given, with the out flag, we have told it to save that to a file called plan.out. And that is because we want to save the set of changes that we're making. This is another additional layer of safety, where we are ensuring that only the changes that we have eyeballed in our console are the ones that are going to get applied. So you can see, plan was saved to plan.out. Once we're happy with it, we can apply it. Now, one thing to note here is that I mentioned before that you can exclude some resources from Terraform. You might have them managed by another tool, or you might just not want them in Terraform. That's okay, I don't mind. But if you go in and manually configure those resources that Terraform thinks it is managing through the console, you're going to get really messed up plans. And you're going to see that you're going to see outcomes that you weren't expecting. So definitely make sure that what you expect is what's there. So Terraform tells us, yes, I made all of those changes that you told me to make. Congrats, your infrastructure is now as you expected.
Awesome. So now we know how to write these changes down and apply them to our infrastructure. We've got them in Terraform. We're making those changes in the cloud. What changes are you going to make? What are you going to build? Now that you're this powerful, you can actually build anything you want. You can create all these things in the cloud. And we've created a few examples for you. We're going to go through one of them. So it's really important as you scale your infrastructure that you keep your code base laid out in a really easy to manage and read way. If any of you work on monoliths of applications, you're going to know that the way you structure your code is really important. The same is true of Terraform. So while we've been working on this project, we've created a repository which we have open sourced today, which is very exciting. It happened like 2 hours ago because we nearly forgot. So can we all see that? I think so. So this is our repository. We've got two directories here, environments and modules. I'm going to go through the modules first. So we mentioned that modules are building blocks of code. They're reusable chunks that do a thing. We've got some in here for the admin account groups. We've got the all accounts are going to have the same roles. We've got a thing for sending messages to Slack. But I'm going to walk you through CloudTrail. Now, CloudTrail is a service which monitors all the API calls in your infrastructure, the ones done through Terraform and through the console, and it matches those to a user, and it outputs it in a log file. So it gives you a full audit log of all your changes. That log file is then stored in S3. So in this module, I'm going to have a look. Modules are made up of variables and resources. So we're going to look at the variables first. These are like inputs to sort of configure your module for your specific environment. So we've got a variable here for an environment that's going to be something like test or prod or admin, and a project name so that you can create some unique names of your resources. So in this case, our project name is My First Terraform. So now we're going to look at some resources. Everything gets logged to an S3 bucket, so that means we're going to have to create an S3 bucket. Can I click a button? I can. Whew, I'm good at this. So our S3 bucket is in this logs file here, and it's a resource, and it has a resource type, which is AWS S3 bucket, and it has a name in Terraform, which I've called CloudTrail logs. The name of the resource in Terraform is how Terraform tracks what it is. It doesn't necessarily match the name of the resource in AWS. We've actually named our bucket just underneath it using those variables that we passed in. So just going to zoom in a little more. There we go. So we've got the project, environment, CloudTrail. So this will be something like My First Terraform, test, CloudTrail, so we know what's in the bucket. We've also made that bucket private because we're not going to have any public S3 bucket debacles here. All right. And so now we need to create our CloudTrail. So this one's a really simple resource. It only takes 2 inputs. Again, it's got a resource type, AWS CloudTrail, and a name, CloudTrail. I'm super creative with my naming. So again, we've used variables to name it, but we've also passed it the S3 bucket we just created. So when you're within the same module, you can pass resources to other resources, and you use the resource type, its Terraform name, and an attribute that that resource type has. So in this case, it's an ID. Different resources have different attributes that you can pass through. So that's a whole module. That puts CloudTrail in your cloud. But how do you put it in your specific environment? How do you use this module? We're going to go back up to the root of this repo and have a look at our environments. So we've laid this out. Ooh. So it has a directory per environment. There's a 101 for your later reading. It's most stuff we've gone through here today. We've also created an environment for admin and test. We're going to have a look at the test environment. So this is the directory you need to be in when you're running those Terraform plan and Terraform apply commands, because this is where it gets all the context for what's in your environment. We have a variables file, again, if we take any configuration inputs for this environment, and we have a state storage bucket, so that's where we're storing that Terraform state file. We also create that bucket through Terraform. But the one we really care about is this main file here. And this has those initial setups that Alex walked you through earlier, so those same lines. And underneath that, it has some modules. So this is our CloudTrail module. They all have a source. In this case, it's a local source. However, that can also be configured remote. You can pull down remote modules and use them in your environment. But make sure you review what's in them first.
Random code off GitHub, it's fine. Don't worry about it. Everything's great.
And then you can also pass in those variables that we defined for that module. So the environment, which is test, and the project name. We've also put a few other modules in there. This is how you build your environment. You stack these modules on top of each other and you reuse them. And you can configure them for different environments. So say I've got something that needs to be really different in my test environment to my production environment, I'll handle that through my variables when I'm declaring it in my environment. And that's Terraform code. So what have we learned here today?
Well, we told you a little bit about how you can reuse stuff. You can reuse modules. You can reuse environments. Devs can spin up bits and pieces so that they can practice things really easily. And you can repeat things, right? You're saving a whole lot of time and mistakes by having all of your infrastructure written down. There's all of the awesome auditability that source control tools like Git give us. And most importantly, I think there's a shared responsibility. The understanding of what we're building, of having tools to communicate about how we're building things and what they're going to be. So we've talked to you a little bit about how it works, how Terraform manages state, how it figures out how to make changes from the code that it sees locally to your amazing magical cloud resources, and how you can go through the stages of planning and applying those, and how important it is to be sure about what's getting applied. We've talked you through a little bit about how to lay out your code, how to create modules, and how to create whole environments. So we made you something. It's okay, you can thank us later. You can go check out our little repo that we've made. We hope that you fork it, that you build on top of it, that you mess around with it, and feel free to submit us PRs. We love code. Sounds great. So yeah, thank you all so much. We're Duck and Alex. You can chat to us on Twitter if you want to. And now you can applaud.